Hey everyone, this is Luke Johnson from Noetic, the Humanities Teaching app. I'm joined today by
Jordan Cline.
And CJ. Hey guys.
So we're doing something very interesting today. Do you believe in magic? Do you believe in sorcery? Well, this show is not for you because we're talking about
Science.
Knowledge. And specifically, we're going to be talking about Thomas S. Kuhn's The Historical Structure of Scientific Discovery. Now, it was my choice this week. It seemed to naturally evolve, some more science words, out of our conversation of Sir Karl Popper's Science is Falsification. I believe we will bring these two behemoths of the philosophy of science in conversation with one another in our discussion section. The way that we have things laid out here today, given the really precise and difficult nature of these essays, I'm preparing sort of a background thing that I'll get out of the way as fast as possible, and then kind of clear the floor so all three of us can discuss the work at length. I believe Jordan will have some information that she will want to sprinkle in as I read the essay quickly of what we'll be covering. But before we go into it, initial adumbrations, ruminations, speculations, vibrations. What do you want to say about this text? Did you guys like it?
How about you, Luke? Did you like it?
That was pretty cool. It's pretty cool. I'm really into Antarctica right now, but it's pretty cool. It's pretty cool. Yeah, no, I think it's great. I want to study more philosophy of science stuff. I like science. Science is cool. What do you guys think? Come on, we gotta sum up some more enthusiasm.
Come on, CJ.
I mean, look, it's super great, right? Because this thing draws distinctions. It just tells us how we make discoveries in science, right?
Yeah, I took a history of ideas course in my undergrad, and we read Kuhn, and this is my second time with Kuhn, and I'm really excited.
Right.
Because he's awesome.
What do you think, CJ?
It's very complicated, the way he weaves what discovery is. Because I think we look at it as something quite simple. Oh, you discovered oxygen, or you discovered the atom. But Kuhn is going to say, oh, hold on. It's a little more nuanced. So I think that's something that is very important when we discuss things, is to go a little deeper and ask more questions. And that seems what Kuhn is doing here with this notion that we all take for granted, that one can discover gravity or one can discover oxygen. But what does that really mean? And Kuhn's going to give us a little treat.
Yeah, he is. So can I get into it?
Yeah,
let's
go.
Just hit me if you want to say something as I go through this, okay? So here's the essay that I've prepared. It's largely free from critical commentary. CJ did a fantastic job of providing critical commentary, so he's going to be kind of the star of the show once I get done with this. So we find this essay within Kuhn's book, The Essential Tension. Here Kuhn wants to illustrate the historiographic revolution in the study of science. The larger revolution is addressed in his landmark text, The Structure of Scientific Revolutions. This essay appeared in 1962, and his topic is the structure of scientific discovery.
I believe this is also the 6th chapter of The Structure of Scientific Revolutions. If you read that chapter in particular, there are a lot of parallels. Mm-hmm. It's just structured a little differently. Yeah. But I thought that was interesting too, that it is not something that is separate from his work. It is something that is embodied inside the massive text that is his opus.
It sort of mirrors extended discovery, which we'll talk about later. I think this essay actually appeared in a couple places before. I think it was actually originally in a scientific journal before it made it into The Essential Tension. But I don't have it in front of me, so I can't remember. Mm-hmm. Until recently, scientists and historians thought there to be no internal structure to scientific discovery. Discovery had been seen as a unitary discovery, not spread out over time and space. Kuhn says the scientific community passed on this idea of unitary discovery by placing so much importance on the goal of discovery. Discovering something is the thing closest to a property right that science affords, says Kuhn. This accounts for why acrimony can break out between scientists and how we get the measure for scientific progress. Kuhn notices that despite how much emphasis is placed on discovery, science has a really difficult time nailing down when discoveries actually occur. Proceed?
Yep, proceed.
Proceed? Okay. Kuhn's thesis is that scientific discoveries are not the things we can ask when and where about. Even if all the data were present, we could still not answer these questions, demonstrating the inadequacy of our concepts concerning discovery. He uses some examples to illustrate this point. For the sake of brevity, we will primarily examine what he has to say about the discovery of oxygen. This is one class of things that could not be scientifically predicted in advance. And also in this category is the electric current, X-rays, and the electron. Let's call these the extended discovery class. Kuhn intimates this much later in the essay. These discoveries caught people by surprise. He will focus on this class of extended discoveries soon, but wants to examine another class of things first. The second class does not present the same problem as the first. What does he mean? He has in mind the neutrino, radio waves, and the many elements that fill the void in the periodic table. All these things were predicted from theory, and men knew what to look for in advance. Let's call these predicted discoveries. It gave them criteria for knowing when their goal had been reached. There's no real debate about when these discoveries were made, unlike the first class mentioned.
So we have predicted discoveries, so those things are already presupposed by theory and by examination that this thing has to be here. And then we have these discoveries that are going to prove interesting for Kuhn, that are called extended discoveries, that we haven't really predicted anything about them, and they're going to cause, as we'll see, some trouble as to, well, how do we even put down a flag of when oxygen was discovered if we didn't even predict it? I'm assuming that's what he's saying.
Yeah.
Cool.
Okay.
Just that.
To understand the problem, Kuhn is first going to look at the discovery of oxygen. For our purposes, I'm only going to go into detailed discussion of the oxygen discovery. It would be redundant yet interesting to tell you about the discovery of X-rays and Uranus. So 3 to 4 scientists have a legitimate claim to the discovery of oxygen. Scheele, Priestley, Lavoisier, and Bayen. I probably butchered some of those names. Scheele's work was done before Priestley and Lavoisier's, but didn't go public until after them. Sometime before March 1774, Bayen heated precipitated mercury yielding CO2. Priestley repeated the experiment a few months later and realized the gaseous product could support combustion and changed the identification to nitrous air, N2O. Lavoisier tested things further and refined instruments and realized it was not N2O or CO2, but a more pure common air. Priestley's further investigations in 1775 would lead him to this conclusion as well. Priestley tested things again in March 1775 and found that his gas was much better than common air and called it dephlogisticated air. This caused Lavoisier to re-examine his own results and conclude that it was a separable component of the air. This is when the discovery of oxygen was completed. So, when was oxygen discovered? Now, Jordan, would you like to say something about Lavoisier? You mentioned something to me before.
Oh, I'll touch on that later.
Okay. So when was oxygen discovered? Many people had obtained samples of oxygen before. They just didn't know what they were dealing with. So to discover something, one must be aware of the discovery and know what it is that one has discovered. If that is the case, how much must one know? Did Priestley come close enough when he identified it as N2O? Did Lavoisier come close enough when he identified common air? What about when Priestley identified dephlogisticated air? We must wait until 1776 to 1777 for Lavoisier's findings where he isolated the gas. But even that can be questioned. Why? Lavoisier mistakenly claimed that oxygen was an atomic principle of acidity, thus causing some to say that oxygen was not truly discovered until 1860, the date of the error's elimination. Kuhn does not think that the ejection works because oxygen became a standard chemical substance long before. It is interesting to note here, oxygen probably would have gained the status of standard chemical substance based on Priestley's work alone. Kuhn concludes that we need a new vocabulary and new concepts to understand this type of discovery. It is impossible to answer the when and the where of these discoveries if they happen by accident or are unexpected. Kuhn thinks oxygen was discovered somewhere between 1774 and 1777, but it is arbitrary to pinpoint the discovery somewhere in there. Discovery is a complex process that involves knowing that something is and what it is. The process extends over time and can involve multiple people. Only discoveries in the second category, aka predicted discoveries, can be known in advance and their discovery be pinpointed. The discovery of Uranus and X-rays are like the discovery of oxygen. I may have skipped over a little bit here. It should be noted, in contradistinction to the extended discovery class, there's the second class. I think I got off to turn off the coffee pot. The second class does not present the same problem as the first. And what does he mean by that? He has in mind the neutrino, radio waves, and the many elements that fill the void in the periodic table. All of these things were predicted from theory, and men knew what to look for in advance. So we're going to call those predicted discoveries.
But we're dealing with extended discovery.
Yeah. Oxygen is an extended discovery.
Okay.
It gave them criteria for knowing when their goal had to be reached. There was no real debate about when these discoveries were made, unlike the first class. So we've got our predicted, and we have our extended discoveries.
Okay.
Is that clear to everyone?
Mm-hmm.
Okay. Just a little bit more, and then I'm going to shut up and let CJ and Jordan. Do you want to say anything else here? Okay. So he says there are 3 characteristics to these types of extended discoveries. Characteristic 1. It begins with the isolation of an anomaly. The anomaly is both inevitable and accidental, meaning the anomaly is the accidental discovery of something that would be inevitably found. To make such a discovery, you need A, the wit to recognize that something has gone wrong and that it may prove consequential, and B, anomalies do not emerge from the normal course of scientific research until both instruments and concepts have developed sufficiently to make their emergence likely and to make the anomaly which results recognizable as a violation of expectation. That's on page 174 of this essay in the essential tension. So characteristic 2. Awareness of the anomaly is only the beginning. What follows is an extended period of time where a person or people try to make the anomaly law-like, which demands observation and contemplation. There is no single point at which the discovery happens. And finally, characteristic 3, Kuhn examines what happens after the discovery is disclosed. Kuhn thinks that predicted discoveries are mere additions to scientific knowledge. The sorts of discoveries Kuhn has been examining, extended discoveries, like oxygen, are not mere additions to scientific knowledge. These discoveries shape what we thought we knew and even change how science is practiced. People who struggle with such phenomena often see their work and the world differently. Very often these shifts in scientific practice are more important than the discovery that precipitated the shift. For the shift in scientific practice can yield unfathomable results, and it would have to logically follow further shifts in scientific practice. You now know how to look for new things. Unanticipated anomalies are precisely the things that bring about scientific revolution. Anomalous discoveries show the need for readjustment, and that is why discovery is protracted in time. Okay, so thank you for letting me get that out of there.
Yeah.
So now let's let CJ and Jordan talk about what they want to talk about.
Sure. So I think what we're really going to do here is discuss the 3 characteristics, because it is a case study for Kuhn to go over oxygen to then give us what the 3 characteristics are. Or I'm assuming that the case of oxygen that you described, Luke, is an example of these 3 things that make up what an extended discovery is. So I'm just going to go through each one characteristic at a time.
Please do.
And
that's a great way.
Cool. Let's go for it.
Discuss it. Yeah, because that's what we're talking about, is the characteristic of discovery, or in particular extended discoveries. So with the first characteristic, I wanted to talk about the point that you talked about, Luke, which was the B, where to make such a discovery you need the, as he says, anomalies do not emerge from the normal course of scientific research until both instruments and concepts have developed sufficiently to make their emergence likely and to make the anomaly which results recognizable as a violation of expectation. So I'm thinking about this in contrast to Karl Popper's essay, which was Science as Falsification, and to give a summary for those of you who have not read it or listened to our podcast, and maybe let me know if I'm wrong or if you want to try to give a little more detail to it. But Popper is trying to get at the idea that science is a negative action, that what you're trying to do, a good science, is trying to falsify a theory one at a time, that you're trying to shake the foundations of that theory and see if it still stands. And if it doesn't, then that means that you have to either fix it so that it works and still stands, or you have to move to another theory. Does that make sense?
Well, yeah. I mean, if you have enough of, well, but we mean fix it, right? There's these ad hoc fixings that we look with Popper or whatever, right? If it's fixed in such a way that it becomes unscientific, not falsifiable, like he said about Marx's theory of history, had a falsifiable dimension to it, but then the followers of Marx kind of propped it up in such a way that it would never be falsifiable. So we have to be careful what it means to amend or fix a theory so it doesn't cross into the non-falsifiable category.
But it almost sounds as if science is a negative action where you have to be trying to falsify something and falsify it and try to say, okay,
but
what if we did this? What if
but
we
there's
did
something
that?
positive to Kuhn's account. You're pointing out attention.
Right.
Popper,
Yes.
You said Paulser was all obsessed with falsification.
And it seems that Kuhn, at least in the point that we're talking about, where he says that instruments and concepts have to be developed sufficiently to make the emergence of these anomalies happen, is that Kuhn seems to be pushing towards an additive view of science. We're not trying to destroy a building, we're trying to build it up. So we have to develop our instruments and concepts enough to make an anomaly appear. And it seems, as you said, Luke, that Popper seems to stand on the negative side. We have to try to falsify in order that weaker theories are separated from the stronger ones.
But isn't that what an anomaly does in the first place? It's like a deviation from the expectation, right? So because in my mind, I saw the two sort of theories almost complement each other.
Yeah, so did I.
So I saw them working together because...
Elaborate on that.
Yeah, I was like, if you have a theory over time, and if you have all these experiments, right, over like generations, decades, the like, and if there aren't any anomalies that appear, and you saw that even with, Priestley and Lavoisier, right? Mm-hmm. They both kept revising, they kept carrying out these like same experiments, and they kept getting these sort of different results each time.
Falsification was absolutely essential to find the anomalies.
So in my estimation, it seems that it almost seems like that Kuhn is sort of working off of the tradition of Popper.
Yeah, that's a great point, because it almost seems like you said that developing a science, in his words, to make the anomaly which results recognizable as a violation of expectation is exactly Popper's point. Is that not what falsification is all about? Testing a theory to see if it violates an expectation.
Yeah.
So then it almost seems that I'm playing this game of semantics if they're both going after the same thing. But I think the part that maybe I tried to ask you guys about is, well, what about the accidental portion of Kuhn's statement? Because I think that maybe conflicts with Popper's mission, because Kuhn tries to take these anomalies as little accidents that will inevitably happen within normal science, and Popper seems to focus on directed and purposeful disproving of a theory, that we're going to look at the eclipse and see if it will prove Einstein's theory of gravitation. It's not, oh, well, let's go on with normal science. Uh-oh, what happened? This happened. I don't know if that maybe is a stretch.
Isn't it wouldn't the contingency, right, of that accident happening then have scientists intentionally test the theory and sort of transition more into like the Popper sort of intentional...
Yeah, well, this raises the question about intentionality, right?
Yes.
So this is the question about, are anomalies simultaneously accidental and inevitable, right? Mm-hmm. So the only way that an anomaly exists, right, is that if you recognize it, right? It took these particular people of genius to identify the anomaly and anomaly in play, right? So I don't know. The thing that I found a little bit murky about what Kuhn was trying to say here is how can you have it both ways, where you say that discovery requires a particular luminous sort of insight into the nature of scientific work, but at the same time talk about these anomalies as if they are inevitable. Because the thing is, like, people were able to bottle air and oxygen all their lives, but it took a particular sort of prudence and wisdom to be able to discern that there was something more going on here than just like I've got distilled atmosphere.
I mean,
so it does. So I guess what I'm saying here is that we have to bank on this fact that some particular people will come along and eventually discover this. But I don't know if any of that is assured.
I mean, it's a function of time, and it reminds me a little bit about Darwin, right? And publishing,
go on
the
about
Order
that.
Species and, and evolution, right? Because he came back from all of his travels with the HMS Beagle, and he came home, wrote everything down, and then he sat on his research for like 20 years. And then it really wasn't until Arthur Wallace sent him this manuscript of all of this writing, which, lo and behold, pretty much had natural selection and all of this stuff, that Darwin said, oh my God, wait, he's going to beat me to the punch. Like, he's going to get this idea out first. So then Darwin had to rush and co-authored a paper with his buddy Charles Lyell, a geologist, and Joseph Hooker, who was a botanist, and they presented this paper, which had some excerpts of his chapters, of his ideas at the Linnaean Society, and that's how it got out. But I think that, to me, it almost seems like there's a function of time in this. And maybe that example's like a lot closer, right, with Darwin and a contemporary. But
I wonder how much of that also has to do with personal attitudes and just personality in general, because there is a great article or essay by Stephen Jay Gould that talks about Darwin's delay, right? Why did he not put out evolution theory in the first place? And there's all these different ideas. Oh, well, maybe he didn't want to put it out because he was afraid of what it could do, and all of these other sort of theories that he was just trying to, take his Promethean fire and hold it close before the world burned down from it. But it seems that
it might have caused a personal crisis for him too.
Sure,
for a lot of his existential and religious ideas.
Right, and it could also be that he was just working on other things at the time that were of more interest. But
like
there is that
fancy.
or just talking about barnacles and all these other things that seem inconsequential. But I think that also takes into account that science also has this social or personable element to it.
Well, it's collaborative, right? I mean, ideas can't exist in a vacuum.
Well, it's very interesting about talk about concurrent discovery.
Right.
The notion that comes to mind. So there's so many types of this, right? So you have Leibniz and Newton working independently one another, developing calculus, and then you have who we're talking about here, Darwin, and who is this?
Arthur Wallace.
And Arthur Wallace developing evolution simultaneously.
Yeah, I mean, even like,
and then you have people. Then you have something like oxygen, where it's going down the assembly line of discovery, and then you have these things like Higgs boson particles.
Yeah, and you have to think about too. Priestley and Lavoisier were in correspondence. Like, they talked, they met, and stuff like that. So I mean, they pretty much collaborated on it.
And that's kind of the norm for a lot of discovery these days. I mean, you have when you have a scientific journal, it's not weird for there to be like 7 co-authors of a paper or something like that. So how do you give credit? How do you give that particular scientific property right to a particular person? It's like you would need like hyphen, 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 hyphen,
Well, I think this goes into, if I may, goes to the second characteristic that Kuhn brings up about extended discovery, and is that what you said, that there is no single point at which the discovery happens. And I think it's something that we have to really wrap our heads around, because like you said about oxygen, all these gentlemen and lady, if we want to include Mr. Lavoisier, strode different paths in order to make this anomaly law-like, right, where we get N2O and dephlogisticated air and common air. And it seems that we have this murky affair here that it can be interpreted, I think, that Kuhn is saying that discovery is this subjective and therefore relative thing that, well, everybody has their own interpretation of what this oxygen thing is. So what's the quote unquote real objective version of oxygen? But this is where it gets hairy.
Yeah. Now I want to insert this definition of nominalism. So let me know when I can do that. Okay.
Sure. So there's this great little introduction to Kuhn from this publisher named Polity, Polity, and it's their Key Contemporary Thinkers series, and I believe it's by Mr. Reed and Mr. Chirac, and they refer to how there are, quote, crude and sometimes catastrophic misinterpretations Kuhn suffered from mainstream philosophers and postmodern relativists alike. I think what they're saying is that Kuhn, if we take these ideas to the extreme, that Kuhn is being perceived as attempting to couch the objectivity of science into relativity, social constructs, paradigms, as he calls them. That science is purely relative and does not perceive a grounded reality.
This is a huge point. We need to talk about this extensively.
This is scary.
No, why?
Well, not scary.
Embrace the ambiguity, my friend.
Yeah. Well, I don't know, but that creates problems for scientists.
Let's talk about it. Let's give CJ a chance to finish his thought.
Sure. So I think Kuhn, the funny thing is always like how you can never really control how people perceive your work, and I think Kuhn, throughout postscripts and future works, tried to make his opinion known, or not his opinion, but his ideas known, that he was not trying to destroy the sanctity of science, at least of its objective form. And I'll quote the postscript. I can't remember what year or what edition the postscript came in from the Structures of Scientific Revolutions, but I'll quote it otherwise. Scientific development is a unidirectional and irreversible process. Latter scientific theories are better than earlier ones for solving puzzles. That is not a relativist position, and it displays the sense in which I am a convinced believer in scientific progress.
Oh, cool. You said progress. Yeah. Okay, interesting.
Right. So this is a long-winded way to ask you guys a simple question.
Please.
Do you think that Kuhn is trying to show here, no matter how much we can extend his opinions or not, that discovery is merely relative, a social construct, a property right that scientists and maybe historians use to create some sort of quote-unquote narrative?
I want to inject a term that will help our conversation. Okay. I don't want to cut you off, Jordan, but so there is I want to give us other options between this dichotomy between objectivity and relativity.
Sure, okay. Because it is still even
right. I just want to introduce a new concept for maybe us and for other people who are listening or watching.
Clarification. Let's do it.
There is a position called nominalism. Okay. Okay. So this is just a Wikipedia definition, and if you go to the Stanford Encyclopedia of Philosophy, there's different types of nominalism, and it goes on and on and on for 30 pages. Go check it out. But the doctrine of nominalism, and I have to say, I'm finding myself taking a shine to the doctrine of nominalism, given how volatile science is these days, where we're finding particles all the time and new types of matter and things like this. But it's the doctrine that universals or general ideas are mere names without any corresponding reality, and that only particular objects exist. Properties, numbers, and sets are thought of as merely features of the way of considering the things that exist. It was important in medieval scholastic thought. Nominalism is associated particularly with William of Ockham. Okay, so it would seem to me, I'm only going on what I know about Kuhn from this essay, right? So I don't think it would be fair for me to paint him in his other texts. It would seem to me that his viewpoint is more compatible with a nominalist point of view, in the sense that these can be puzzles that can be solved, and the progress is going on in the technology and whatever that we use to discern these entities, right? But are these entities and these discoveries and the properties that all these entities, do they really exist? Are they really are we really, through science, unearthing a description of physical reality? I'm not getting that. I'm not saying you can't have that view. I'm not saying you can't be a scientific realist or an objectivist or whatever we want to say would be different from this nominalist perspective. But given the social constructive nature of scientific paradigms, it seems like nominalism would be a more fitting viewpoint with what Kuhn is describing here. That's my personal belief, and I'm finding myself drifting towards that. Now, let's let Jordan weigh in.
Jeez, OP, because I have a quote that I've just been waiting to say, because
Do
that
it.
might help us.
Do it.
Discoveries have a proper internal history as well as a prehistory and a posthistory. So there is a reality that exists.
Whose quote?
This is Kuhn's. This is from Kuhn. So,
From this essay.
yes,
Okay.
from this essay. So, I mean, if we think about it, right, so proper internal history as well as a prehistory and a post-history. So this isn't just us projecting our feelings onto this or anything like that. There are things that exist in the culture before these theories come into existence, when they come into existence, and afterwards. And if this kind of reminded me a little bit of sort of like Hannah Arendt, right, where there are things that persist in cultural memory. So for me, this whole kind of like relative thing, I don't know, that doesn't...
I tend to think there's an objective dimension and I think there's a real and an unreal dimension to it.
So
Can I have it both ways?
So is the real dimension then that all of these men are observing, and women are observing, this gaseous element or whatever element it is?
They're looking at something.
They're looking at this
They're,
thing.
and they're all looking at it the same way, through the same instruments, or they're trying to.
Yeah.
So that's the objective, real part of it. But the thing they're looking at can change when new evidence and anomalies come to light.
Right.
And it may shift. So that's how I've got this shifting thing underneath the objective process that's examining it.
I think one thing that we haven't really touched on, though, is about the instruments, and to me that seems really important.
That's huge.
Because Lavoisier had, because he was like not exceptionally wealthy, but he was like pretty much like a member of like the noble class, and he had literally, I'm not kidding, like a world-class lab. Like he had one of the best labs in Europe. So I think that when it comes to like instruments and sort of coming up with these anomalies, I think that the precision and accuracies of instruments, in my mind, that seems like one of the most essential things.
No, what do you think it's so essential? What I mean, besides it being an interesting factor of history, can you elaborate on that?
Yeah, I mean, I don't know. It just seems to me that if they're all sort of looking at the same thing with the same objective, but they're all arriving at these different conclusions, it seems that to me that the
they're
accuracy,
not wildly different conclusions,
but they're still. I mean, when it comes to chemicals, a couple atoms, right, make a difference.
Right. Well, this raises a very interesting question, right? This raises a very interesting question where you could get into the relativity of science. Let's just. I'm gonna put out a crazy idea. Okay. If you start from different assumptions, do you get radically different science? Right. For instance, like that's why. So you have like creation science, right? So the starting point for like creation science, right, is going to be like young Earth or something to this effect, right? Where like dinosaurs were contemporaneous with man, and all those like fundamental assumptions are going to lead to a radically different science, or possibly one that is done when you have a Big Bang and a very old Earth or something like that, and then you have this splitting of science. Now, some people will be like, well, that other thing is not science, right? But all I'm saying here is you could have a situation where you have people doing science in different ways and coming to radically different conclusions if science is not an ultimate description of reality.
And I think this is where
that is the concern about relativity.
So does it mean like does science have any absolutes then?
I don't know.
Well, this is where I think maybe you can we can talk about this part too when you're talking about, he does say that there is a prehistory, a history, and then a post-history. But I suppose it almost goes to, do the victors write the history? in some sense saying, okay, well, who's to say that oxygen, quote unquote oxygen, is better than dephlogisticated air or N2O? Maybe it works better within the paradigm of the moment, or at least the scientific theories of that time, but it almost seems that we're defining things by looking backwards. I don't know, because we say like, oh, somebody discovered oxygen, but like you said, they're thinking about it in different ways.
Yeah.
And we have to go back and say, well, he wasn't looking at dephlogisticated air, he was looking at oxygen.
And there was questions about even Lavoisier, did he find the oxygen, because he talked about it as a principle of acidity, which got disproved 90 years after the discovery, or like 85 years after discovery. Some people would more radically claim that oxygen was really discovered in 1860, which makes a very interesting thing. Is like, well, what if something else that we believe today is totally overturned, and then the discovery happens in 2050?
So that almost seems that I would argue, maybe you guys can test me on this. Would that mean that maybe discovery is even longer than we think? That maybe the biggest part of discovery is coming up with a definition that can be agreed upon almost universally in the first place?
Well, but that's sort of, it becomes sort of arbitrary. But the thing is, if it's much longer, then you might have to say that it's endless. So
Infinite.
the only way that you could ever have non-arbitrary distinctions about when discovery actually occurs is when you finish science.
Yeah.
Because
and when do you finish science?
Yeah. So long as there are still things to discover, the possibility of rewriting when the discovery happens and it getting new traits and new things.
Well, not to mention people go back and they re-examine things too, so it never ends.
Well, that would be, it's a very interesting question, is does science end? Do we ever, and it seems like, as far as what I can tell about advanced particle physics, no. It seems like what they're saying in advanced particle physics is that we have irreconcilable models and that we have to, that 95% of what we consider to be the universe's reality is made up of dark matter and dark energy, which we have no understanding of. So it seems, if we've been around this long, we only understand 5% of what reality actually is. So it doesn't look like we'll ever get close to it. And then maybe there'll be something beyond that. You know?
So there will always be a job market for scientists. Always.
If there's any consolation.
The one, if not the most important takeaway, folks.
Yeah, so maybe saying that it is relative isn't really giving due credit to Kuhn. Maybe he's just saying that discovery is more nuanced than we think it is. That maybe this idea that we can't really come to definitions is part of the anomaly thing, right? Where maybe there's a glitch in the system that we have to take into account with a certain definition that, wait, hold on, this definition doesn't agree with this part, that's an anomaly. Or wait, this definition doesn't work with this component of the anomaly. Then maybe it still works within Kuhn's characteristic. All right, now... But do you want to move to the next?
I think we should move to the next one, unless Jordan has something more she wants to say.
Yeah, that was great, guys.
All right, well, so why don't you bring us to our next point?
Oh my goodness. So
we're like really contemporary here, right?
Yeah, so now we're moving to the third characteristic here, which is talking about how predicted discoveries are mere additions to scientific knowledge, while the extended discoveries are ones that aren't just additions to scientific knowledge, but change the scope of how we look at things.
Revolutionize things.
Revolutionizes things even beyond just, oh look, let me add another thing on the elemental table or the chemie whatever table of elements and stuff. So what I wanted to bring up and maybe have you guys help me discuss here is, can a predicted discovery be more than mere additions to scientific knowledge? Can it also possess the characteristics of a extended discovery? And Luke, maybe you can help me with this. The example I think of is the Higgs-boson particle, which, if we took the definition of Kuhn, could be categorized as a predicted discovery. I'm not really aware of the history, but I know that it was theorized around 1964, and maybe a little before that. I have to go into further detail, but I do know that we didn't observe it first. We theorized
It was
about
on the chalkboard.
It was on the chalkboard first, so we could say it's a predicted discovery. But it has profoundly changed the way we look at the world, and we don't even know the potential uses of this particle, what it could bring into the world, or what it could even do. That could just blow our minds, even though we know that it's a thing. So I suppose, does Kuhn's definitions of what we can get from extended and predicted discovery seem less nuanced than perhaps?
Well, look, I think we could write. We could do a whole lecture and a whole lecture series, and then you could write whole books about the Higgs boson particle.
Sure.
Okay, you've got two questions. You've got, can a predicted discovery have the same qualities as an extended discovery, which is a separable question from whether or not the Higgs boson particle is a predicted discovery. Now, I want to give a little bit of background information on Higgs boson, because I think that might be the easier question to address first. Do we care?
No, go ahead.
Is that okay?
We need to
Fill
be
us in.
thorough.
All right. So the Higgs boson. This is from Wikipedia. The Higgs boson is named after Peter Higgs, one of 6 physicists who, in the 1964 PRL symmetry breaking papers, proposed the Higgs mechanism that suggests the existence of such a particle. On December 10, 2013, 2 of them, Peter Higgs and Francois Englert, were awarded the Nobel Prize in Physics for their work and prediction. Engler's co-researcher, Robert Brute, had died in 2011, and the Nobel Prize is not ordinarily given posthumously. Although Higgs' name has come to be associated with this theory, several researchers between about 1960 and 1972 independently developed different parts of it. Okay, that sounds like extended discovery and not predicted discovery. All right. Okay. Furthermore, all right. So there's 2 names here.
Yep.
There's Higgs and there's boson. What's a boson?
Where's boson?
Boson. In quantum mechanics, a boson is a particle that follows Bose-Einstein statistics. Bosons make up one of the 2 classes of particles, the other being fermions. The name boson was coined by Paul Dirac to commemorate the contribution of the Indian physicist Satyendra Nath Bose in developing with Einstein Bose-Einstein statistics, which theorizes the characteristics of elementary particles. Examples of bosons include fundamental particles such as photons, gluons, and W and Z bosons, the 4 force carrying gauge bosons of the Standard Model. The recently discovered Higgs boson and the hypothetical graviton of quantum gravity composite particles, mesons, and stable nuclei of even mass numbers such as deuterium with 1 proton and 1 neutron, mass number equal 2. Whatever, blah 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 science.
Yeah, I was gonna say.
Okay.
What's the crux of that? What's the crux of that? In English.
All right. So in
please.
summary, this doesn't look like a predicted. Even though they built CERN. Even though they built this giant atom smasher, right, to find the Higgs boson particle exclusively, and then they fired it up again recently. It looks like it was predicted, and then they found it, and it all kind of fell into place. This Higgs boson particle has so many fingerprints on it. I mean, it's the Higgs mechanism, it sounded like there were at least 6 people involved from 1960 and 1962, and not to mention the contributions of Bose and Einstein. So this seems like an extended discovery.
So
close?
That would make me think then, maybe to go back to the initial question, that maybe this is my answer. If you prodded deep enough into a predicted discovery, it becomes an extended discovery.
Yeah.
So that extended discovery is the only type of discovery there is.
Right.
And that's everything.
That's a fantastic point.
I'm glad you brought that up because that wasn't exactly where I was going. I was like, oh my god.
Yeah, I think they might be one and the same. But why would that be a problem? I don't know.
Not a problem. I think it's very fascinating.
Right. I mean, what were our examples? We'd have to. What did he say the predicted discoveries were? Neutrinos, electrical current, and what was the other one?
Let's see here.
There was one other.
The electron.
The electron.
Yes, electrical currents, X-rays, and the electron.
Yeah.
No, X-rays were extended discovery.
Oh, I'm sorry. You're right. Oops.
Electrical current, electron.
Electron is still the yeah.
So I don't know. I'd have to look into.
We'd have to look into.
To be continued.
To be continued. But I think it seems like it. If you did look hard enough, it almost would seem like the distinction between predicted and extended may change. You know, the only thing it seems that extended has going for it is that there's something shows up that shouldn't be there. Mm-hmm. That would seem to be the difference between it and predicted, because the predicted they know what they're looking for. With extended, something comes out of the clear blue and they're like, what was that, right? Mm-hmm. And also it's highly disruptive to the way that science is practiced, so that they have to go back and revise all the concepts and all the technology used to make the anomaly law-like. Mm-hmm. I guess the only thing that really seems to be distinguishing predicted and extended is whether or not there's an anomaly. It comes down to the anomaly.
Though I wonder if you predict something and then an anomaly comes into play later on, if that still counts. It just seems that it's more nuanced than just black or white.
Well, you could have a predicted discovery possibly become an extended discovery. That's a possibility too, maybe? Is that a possibility? That you would have a predictive discovery that then encounters something anomalous, and then that leads to something else that's extended, so it becomes this chain of predicted and extended? Could that happen? Do you see what I'm saying?
Yeah.
Yeah, I mean, so what if there could be a function of, you conduct this experiment and you get the predicted result, but maybe like the means or like the mechanism in which you arrived at that conclusion was totally sort of unpredicted. I don't know.
No, that makes sense. And I think maybe if we dug up more examples,
we need some more research on it.
Then we could very well find that.
Yeah. Well, all right. We're brushing up at we're brushing up at 50 minutes here.
Would you like to end with your question?
Oh, well, I think I kind of answered my question. I was just kind of curious about whether or not there was scientific progress. Mm-hmm. And it seems to me, I'm not so sure we can have access to physical reality. I have that sort of nominalist view, but it seems like we have progress in regards to the techniques and technology that we use to ascertain what we believe to be actually existing. So it doesn't really bother me. It doesn't really bother me that I think the real problem is that the way that science is communicated within our society today is that science is put in juxtaposition to say everything else, where people go around and be like, I believe in science and therefore I believe in truth and my truth is better than your truth. Mm-hmm. And in reality, I think what we're looking at here is that it doesn't have the metaphysical existential status that people think it does. That it's actually murky, ambiguous, often wrong. I look at it as a technique. So I just want people to ratchet down their zealousness and their dogmatism about science. Still value it and understand that it's very effective for helping us cope in the world that we live in, but that maybe to pump the brakes on this ultimate claim to reality. That's the big takeaway for me. I'm not trying to evangelize to people about this particular viewpoint. That's what I'm getting from the research we've done so far. I reserve the right to change my mind in the future if I encounter
an anomaly.
And I'm
tells you otherwise.
Yeah, I'm showing the physical reality of the universe. What do you guys think? Where are you on this question about the ultimate reality of nature?
Or just whether Kuhn has any
Kuhn and Papa.
progress.
What do you guys think?
Well, I don't know. I'll start. I think it's great that you mentioned Darwin, Jordan, because I think it goes along with this question, because it seems like we're asking, does science progress towards, as Kuhn says in the Structures of Scientific Revolution, quote, draws constantly nearer to some goal set by nature in advance, right? I think that's the question, right? Can we get closer and closer to an objective reality, or to the main essence of a thing? And it's interesting because outside of this essay, in I think that Structures book, Kuhn seems to give an answer here where I'm taking from page 170 from Structures, but I'll quote him where he says, "In the sciences, there need not be progress of another sort. We may, to be more precise, have to relinquish the notion, explicit or implicit, that changes of paradigm carry scientists and those who learn from them closer and closer to the truth." Now, that could easily make somebody think, oh my god, there's no truth, that Kuhn is a relativist and nothing exists, like you said, But I think what Kuhn is doing is he's going to set up a comparison to Darwinian evolution and say that the lack of a set goal for Darwin's theory is similar to science, where he says, like in Darwin's theory of evolution, that man and animals, quote, were products of a process that moved steadily from primitive beginnings, but toward no goal.
Complex, but directionless.
Yes, starting from primitive beginnings,
yes,
towards complexity that does not have a goal. So perhaps we can say, yes, scientific progress is possible on Kuhn's view, but does it mean that we're going forward towards some idealized and preordained goal? Maybe not.
No.
But even in this essay that we have here, extended discovery is predicated on anomalies, and could we compare that to Darwin's happy accidents that happen in evolution, or that some things just seem to just appear out of nowhere from develop? We develop. Here's some kind of weird genetic defect that turns into an advantage and gets propagated again and again. I suppose for me it makes science seem that discovery is a big part stumbling about rather than marching confidently.
Yeah.
I mean, does that make sense?
I think we're just kind of fumbling in the dark, trying to find our keys. Mm-hmm. that's the way I view science.
Yeah. So it seems to me maybe it's a little more nuanced than maybe just like we're not making progress, but it's almost just like, well, what's the end goal? Like you said, what's the end of science? Like we said earlier, like, okay.
It would seem like the end is not to arrive at ultimate truth, but to make it so that we can live better within the world. That seems to be the goal.
Yeah.
That's how I've made my peace with it.
Yeah. What do you think, Jordan?
Yeah, I don't know. I think it's interesting because in sort of all this talk of this sort of accidental stuff, right? You think that it's purposeless, but it's kind of funny because I almost think of it almost like sort of like a scatter plot where you get all these kind of like weird points everywhere kind of popping up, but then you have this one unifying line or this sort of unifying arc that's sort of a function of time and progress. So it's like, yeah, like to your point, Luke, I don't think it's really like looking for the ultimate like truth with a capital T, but I think that as long as it seems like this like sort of trajectory is towards a better understanding, and that's through learning that we screw a lot of things up.
And that we're not...
And we learn more about ourselves and the physical world that we live in through a lot of blundering.
And so are you saying that trajectory, it just never ends, that's just going to keep going, just a line that just...
Kant would be important here, yeah.
Just keep going.
Yeah. All right. I think we did a good job. It was good.
Thank you, guys.
You guys have anything else you want to say?
Oh, actually, one shout out before we go, because I forgot to bring her up. You guys should look up Marianne Paul's Lavoisier. She's really cool. She was Lavoisier's wife and basically was a translator, lab assistant, and without him, a lot of his work would not be possible.
It's so amazing how many women don't get the credit for these
really
towering figures of science and literature. The more we dig, isn't that what we find out?
So just go look her up, admire her, love her as I do.
And just know that when we say Lavoisier, it could also mean the Lavoisiers, as in the pair.
Yeah. Exactly. So that's one thing I wanted to sprinkle in before heading on out.
Good Easter egg. Okay.
Yeah.
All right. Thank you, everybody. Appreciate you joining us.
Bye.
Download the Noetic app. Bye.